Hi, I'm Mike Ward. I want to show you how you can construct a Markowitz efficient frontier and find the optimal portfolio. So I am sharing with you my Excel spreadsheet, which has been set up to do this. And I am just plotting to start with the top 40 companies on the Johannesburg Stock Exchange. And you can see that this is where they sit in terms of their standard deviation and their monthly return. That's like the average monthly return they've had in the last 2 years. And you could see where you should have been in the past, let's put it that way. And you'll find some have done well. Standard Bank was up here, surprisingly, and some have done badly. Here's Old Mutual sitting right down here, which is not a good space to be in. Now, there's the risk-free rate. In fact, I just took a monthly rate for that. And this is the current optimal portfolio, which is simply an equal-weighted portfolio of the top 39 shares actually in here. And you can see it sitting there. So just taking an equal weighted portfolio would have been not a bad start. But we haven't even tried to see if we can get anything better than that out of this. Now let me show you the data that we're looking for. So first of all, I have downloaded the total return indices. So these include dividends. So they kind of look like share prices, but they're actually not share prices, and they won't compare with the share prices that you see there. But the beauty of them is that they do include dividends. This is the list of companies that are on the top 40. They're actually 41 at the moment, but I've excluded 2 because the spin-off from Naspers and I can't remember the other one, Process and something else, didn't have a full set of data. So here are these are the share prices, again, not share prices, but TRIs. I've just rotated them. And so we've got 2 years of data going down here. This is monthly data, and we've got 39 shares going across here. And obviously we can't work with share prices. We need share returns. And so here is my matrix of share returns. And we obviously lose the first one. And here we are. These are I was going to say these are log returns, but they're actually not log returns. We could maybe fix that. I don't think it'll make a huge amount of difference, but really we should be working with log returns here. And so you can see I've got a matrix of these, and if I just highlight the whole matrix here, like that, you will be able to see in the top left-hand corner that I've actually labeled that matrix as returns. If I shrink this smaller and smaller and smaller, there you are. You can see it's got a label there, which is just going to refer to that whole matrix. At the bottom, just to show you here, I have also calculated the average return over the last 12 months. So in this case, I did use a log return, and you can see I'm taking B26. I don't know why I didn't use the last one. It should have been B27. I've taken the share prices here. Okay, and and B15 and divide that by 12. So this gives me just like a momentum type of thing. Over the last 12 months, which shares did better and which did worse. And I want you to notice that we are including in all of this data here the very bad performance that we saw in March as COVID-19 hit the world. So a lot of these numbers are bad, a couple of better ones. We've got Anglo doing better and so on, but I've just included them in the data. So this is just pulling out the mean and standard deviation, and that is what I'm plotting in this chart over here. So that's what we've done so far. Now, if we want to optimize this, we need to get the correlations. We don't really need correlations, but it's something that we're familiar with here, and I thought I would show you how to do it. So first of all, I have set up the correlation matrix here. And what we've got to do is fill this with the correlations. So Chris Muller has given us a very nice VBA function called M correlation, because Excel only does correlations between two shares. So this one will enable us to do a whole matrix of correlations. And so you can either highlight the entire area that you want the answer to go in, which is what I've done at the moment, or you can use the resize function. So maybe we should use the resize function. Let's try that. So if I type in here equal resize, this function figures out how big, you see, the Excel needs to know how big is the space to put the correlation matrix, and it needs to be able to figure that out. So you can either tell it by marking out the area first of all, or you just use this resize function. And then we're going to tell it, we want the M correlation over here, and you can see there it is. That's the matrix correlation function. And then it must do this on the matrix I showed you just now, which I called returns, which is that matrix there, like that. And then I'm just going to close the brackets twice. And now I have to push, because this is an array function, not just enter, but shift control and then enter. And you can see we've got the correlation matrix. How nice is that? And you can see here's just the diagonal of ones coming down here, everything perfectly correlated with itself. And if you wanted to use this, you'd try to find companies which are uncorrelated to put into your portfolio. So we're actually not going to use the correlation matrix. We are going to use the covariance matrix, which is just the unstandardized form of this. And you can see on my next tab, I have already done that. I've also coded it up. So we have a covariance matrix and we have a correlation matrix, just to kind of give us a feel for what the data looks like. Then we also need to know, we know what the historical returns were for these companies, but we want to we would like to kind of get a sense of what's likely to happen in the future. If we have no idea, then one option is to simply say, okay, we've got the covariances between the shares, and we're going to assume those are the same. The way in which Standard Bank works with Sasol is probably not going to be that much different from the past. So we're going to keep that relationship. But for the future, we need a forecast. So if you don't know, one option is just to come along and say, okay, well, we know on average over the last 40 years, the JSE has given 16%, but this is monthly data. So let's assume every share's got a forecast return of the monthly 16%, if you like, per year. And so that's what I'm doing now. I've also labeled this array over here. Let me just show you. It's called forecast returns, so that I don't have to refer to it as V2 in this sheet here. Excel will know where to find that array. So now comes the heart of this here. And again, I've set up the sheet nicely for you here. At the top, I've listed all the codes that we've got, and there they are running across the top. And I'm starting off by highlighting this row here, which is what I've called the weight. And again, I've labeled that whole row so that it is exactly 39 companies across here. And what I did, as you can see in the formula here, is I just said 1 divided by 39. 39 companies, let's equal weight these companies to start with. And so that gives me 2.6% or thereabouts of each company. And these weights add up to 100%. And I am just adding them up here just to make sure they come to 100%. Then I want to work out what is the portfolio return and what is the portfolio standard deviation, so that I can plot that on my chart over here. And you can see if I go to the chart, that is what I'm using to plot that red dot over there on the chart. So coming back to the weights, here's the formula for working out the weights for just 2 companies over here. But we've got 39 companies over here. So you can sort of see we need the weights. Weight of the first one times the return, expected return on the first one, etc. Add them all up for 39 companies. And we're going to use a little bit of matrix algebra here. So mmult is an Excel function, matrix multiply. And I am taking this array of weights and I am multiplying it by that column of forecast returns that we saw over here, which is all the same for now. And if I do that, let me just show you. There's the formula. It's an array formula. So I push Shift Control Enter, and it just does it as quick as that. To get the portfolio standard deviation, it's a little more complicated. Again, we've got not just 2 companies over here, but we've actually got 39. And we need to get the weights and the standard deviations, and we need the covariance. So here is the formula that we need to do that. Looks a little bit complicated, but it is the same story as we had before. These are array functions. We're using the Excel's matrix multiplying function to do this. And we are using the covariance matrix and the array of weights to do this. And we're taking the square root here because we need to get the standard deviation, I guess, of all of that. So Shift Control Enter gives us 6.9%. That is our portfolio's standard deviation. I'm plugging in a risk-free rate because we also need to tell Excel where that is. Just going back to our chart again here, you see we need to tell Excel where the risk-free rate is here, because it's got to when it optimizes this, it's got to take this distance here, that whatever the return is on the portfolio minus the return on the risk-free rate, and it's got to try to increase this distance over here. We want to maximize the Sharpe ratio, which is the portfolio return minus the risk-free return. That's why we need the risk-free return divided by this distance over here, which is actually just the portfolio standard deviation. That's why we need all of those things. So if we go back here, you can see here is the risk-free rate. And to get it, I just said, well, let's assume that, you know, long-term government bonds are going to be about 8%. That might be a little bit too low. You can change this. Let's change it. I'll make it 10 if you like. And we're going to make that monthly. And then it needs the Sharpe ratio. We're going to calculate the Sharpe ratio. And you can see it's taking the portfolio return minus the risk-free rate divided by the portfolio standard deviation. So that is that angle that we wanted to maximize. And at the moment, we haven't maximized that at all. It's just sitting at 0.07. So we're going to use Excel's solver function to do this. And I have already set that up. If you go to data, somewhere across here, you're going to find solver. And you're going to see it's set up for us to maximize the Sharpe ratio. So what's its objective? Well, it's going to take B12, which is the Sharpe ratio. And what must it do? It must maximize it. What can it change? Well, it can change these weights in the shares. It can change how much it's got of each share. But there are some constraints. First constraint we want is the weights must add up to 1. And the second constraint is that the weights must be less. I don't want it to put all of our money into one share. So I'm telling it can't put more than 10% into any one share. So it must at least pick 10 shares. And this weight, I'm actually just going to change for now. I'm going to say that it cannot be less than 0. So we'll just put that. And so there are our constraints. And then we just must tell it to solve and hope it can find a nice solution. So it's trying to now, it's running away. You can see it running through various options here. And it says it's found an optimal solution. Would you like to accept that? We're going to say, yeah, let's accept that. And you would have noticed the Sharpe ratio has gone up a bit. If we go and look at our chart over here, you're going to see that our portfolio moved to there. Now, so it's done its best. What's stopping it doing any better is that we gave every share the same expected return, which was 16% divided by 12 months. And so it's forced to keep the return sitting over here at 1 point, whatever this is, 1.3% or something over here. And so that's a bit of a constraining function. What we would like to do, if you have a look at the weights, we can got a chart of the weights. It's saying these are the shares that it needs to get that portfolio. And you can see it's pretty bimodal. You're either in or out of this thing. And it's taking a little bit of Anglo Gold. It's taking Brit A, whatever that is, and clicks and a few others. And you can see you're kind of in, or a lot of these companies are just never going to be in here. So it would be we're not unhappy with the covariances here. That's likely to be the same. But these forecast returns, where we just hold everything to be 1.3%, means that it cannot actually move this portfolio above 1.3%, because we're giving it expected returns for everything are going to be 1.3%. So it would be helpful if we could do a little bit better on that. Now, what I'm going to do, just to see if we can't do better on that, is I'm going to go here where we got our returns, and I am going to assume that there's some momentum in these shares. And the ones which did well over the last 12 months are going to keep doing well, and the ones that do badly are going to keep on doing badly. So I'm going to take this array here and copy that. I'm going to go to the forecast returns over here, and I am going to copy and rotate this as values. So I'm telling it go to transpose, and it must do this with values. And watch our array change. So it's now copied those things there, and that's going to give it a lot more opportunity to move. Of course, we're trusting that the momentum will remain the same. Obviously, it won't remain the same for long, but maybe for the next 3 months, we can assume if something's been going up for the last year, and we've had some bad times in the last year, it's going to keep going up, and the bad ones might keep going down. It's just one option of getting some forecast returns. We could also go and ask analysts for what are they anticipating. Look at their predictions on earnings, but I don't have that data, so I'm just going to do this. So I'm going to go back to my weights. I'm going to restart everything back at the same place. I'm going to say equal 1 divided by 39. Equal weight these things to start with, and you can see my Sharpe ratio. Let's just recalc the spreadsheet, make sure it's all working, and you can see my Sharpe ratio now is minus 0.37. That's because there were some pretty bad returns, forecast returns sitting in there now. And but we're going to run solver again. So we're going to go data and solver, and I'm not going to change anything here. It's all fine. I'm just going to say solve, and I'm watching this now with Sharpe ratio minus 0.37, and it says, okay, it's got a much better result. It's got it to plus 0.36. So let's go and have a look at that. First of all, if we plot the weights, you can see it's changed its choices quite a bit. And we've got some that weren't in there, like Naspers is in now, because that actually did quite well during the crash. And if we go and have a look at our other chart over here, you can see it's putting us there. It's saying, now that you've given me some space to play on the return axis over here, that is where I think you should be for the future, assuming momentum works and assuming the covariance matrix holds. And but if we look at our weights, our chart of the weights here, maybe we can do even better than that. Why don't we allow a bit of short selling? Let's run a hedge fund like this. So if I go back to our model over here, I am once again going to start the weights equal. So I'm going to say equals 1 divided by 39. And I'm going to come over here, just recalc it. So you can see we're back to our minus 0.37 here. And I'm going to go to solver. And I want to just change this 1 parameter here, and I'm going to allow it to go down to minus 0.1. So we'll allow 10% of holdings to be short. And I put that in. And so you can see I'm allowing the weights to be between minus 10% and plus 10%. And if I run that, keep your eye on the Sharpe ratio again, and I'm expecting that to be a lot better now. And this is also going to give us a bit of gearing. It says it's got it up to 1.4. That's a lot better. And I'm going to say, fine, if we go and look at our weights, you're going to see straight away we've got a lot more shares in our portfolio. Just about every share is either long or short now. And that's because we're allowing, we're taking the money we make from selling these things to finance additional longs. And so we've got a much bigger portfolio. Let's go and have a look at our plot here, and you can see it's pushed our optimal portfolio right out there. That is a whole lot better. And so this is based on an assumption that we can allow short selling. It's also based on the holding correlations, our covariance matrix being the same as it was in the past. I'm not too worried about that, but we're also placing quite a lot of weight on a momentum strategy that the future will kind of look like how it went in the last 12 months. But it's worth a try. I hope you found that interesting.